Amidst the despair and tragedy of Spira is a pastime that has lasted 1,000 years.
Blitzball!
The troubles of the world melt away as fans cheer on their favorite team of blitzers. One of the iconic symbols of Blitzball is the unique ball that lends the sport its name. Wakka wields one of these balls as a weapon in the game, and he's got one hell of an arm because he can kill fiends with a simple throw of the ball. Just how much energy is behind the ball of death Wakka sends towards those flying eyes? Let's find out. Alright, to find the energy behind the ball, we have to solve a simple equation. The kinetic energy of the ball is equal to 1/2 the mass of the ball times the velocity of the ball squared. And in order to solve the equation, we need to find a few variables. First, we need to find the mass, which can be found by multiplying the volume of the ball by its density. To find the volume, we need to use the volume formula for spheres. But in order to solve that, we need to know the radius of the blitzball. Now we can do all sorts of estimations using Wakka's height and the length of his arm to try and guess the diameter of the blitzball. Or we can look on the Final Fantasy wiki page, which says it's about 30 centimeters in diameter, and take that at its word. So that means the radius is 15 centimeters, and putting that in the equation gives a volume of about 14,137.17 centimeters cubed. Now to find the density of the blitzball, we're going to have to make some educated guesses. We can't use its behavior in the blitzball arena because the water there has been infused with fireflies to give the players gills and super swimming abilities. There's really only one scene that gives us any clues as to what the density of a blitzball is, and that's the scene after Sin has attacked Kilika. As he controls a tornado of wood or whatever he's doing over there, we see a blitzball float past. We can see that half of the blitzball is below the surface of the water and half is above, meaning that the blitzball is half the density of the water. Now since Kilika borders the ocean, we know the water isn't fresh water, but seawater, which has a density of 1.02 grams per cubic centimeter. So the density of the blitzball is half of that, which is 0.51 grams per cubic centimeter. So now we finally have both values we need to find the mass of the blitzball, which is 7.209 kilograms, or about 16 pounds. That's the weight of a bowling ball. It's starting to make sense on why Wakka can kill things with a blitzball now. But that's only one part of the equation. We still need to figure out how fast he's throwing it. After all, if the ball is only moving like 2 miles an hour, it isn't going to do much damage. Now velocity is broken down in a simple way. It's the distance an object travels divided by the time it gets to get there. We can measure the time it takes for Wakka to hit a target quite easily. We'll record a battle and count the amount of frames it takes for the ball to hit its target after release. We'll use the battle against Ochu since Ochu can live a hit from the blitzball. Slowing the recording down, we can see it takes 8 frames from release to hit its target. And since the footage was captured at 30 frames a second, we know that 1 second equals 30 frames. So if we divide 8 by 30, we find out that it takes the blitzball about 0.27 seconds to hit Ochu. Now, distance is a bit of a problem. There isn't a fixed distance to the fiends in a battle, and it can change depending on the battle and Wakka's position in the party. So we need a way to approximate the distance to Ochu. Here's an idea. We know that Titus, or Titus, or whatever you want to call him, is 5 foot 9 inches tall. We can observe his stride and use someone of a similar height to replicate it to approximate the distance to Ochu. Now where can we find someone that's 5 foot 9 and would be willing to do some light exercise for the fake science of a video game? Oh, well isn't that lucky? So replicating Titus's attack stride 5 times and averaging out the distances gives an average distance of about 3.82 meters, give or take a half a meter or so. So we know the blitzball travels 3.82 meters in 0.27 seconds. Now we need to bump this up to the distance traveled in 1 second, and we have a speed of 14.33 meters per second, or about 32 miles per hour. So Wakka is throwing a 16-pound blitzball at around 32 miles per hour. With that mass and that speed, Wakka is generating 740 joules of energy, which is about as much energy as a 100 mile per hour fastball. I can tell you what, I certainly don't want to be on the receiving end of that. In fact, there have been major injuries caused to baseball players because they've been hit with a baseball. In 1937, Mickey Cochrane was knocked unconscious and hospitalized for 7 days after being hit in the head with a pitch. And in 2005, Adam Greenberg got a compound skull fracture after being hit in the head with a 91-mile-per-hour fastball. One player even lost his life. Ray Chapman of the Cleveland Indians died after being hit in the head with a pitch. So you see, that ball that Wakka's throwing really could kill somebody. You know what? Seymour would probably have an easier time trying to become a blitzball instead of Sin. That way, he could kill people using the one thing that Spear uses to escape death. No one would suspect it. Could you imagine a blitzball flying around with Seymour's hairdo? That would be hilarious. That should have been his final form, Seymour Blitzball. Thank you for watching and see you Jeez. So what happens after Laura fights off an almost immortal being and opens up her hidden realm of Yamatai to the world? No one believes her. They discredit her and mock her.